graphing quadratic equations. Remember the formula for that is y equals ax squared plus bx plus c. There are 4 steps involved. First you have to find the axis of symmetry, next you find the vertex, you fill in the tables, and then you graph. So on number 1, you need to find the axis of symmetry. Remember back to the last lesson, the way you do that is using the formula negative b over 2a. So in this case, your b is 0, so it would be negative 0 over 2 times a, which is 2 times 1. In this case, it would be 0. So your axis of symmetry is x is equal to 0. Okay, the next thing that you do is find your vertex. You do that by plugging in your x value everywhere you see it. So you get y is equal to 0 squared, so y is equal to 0. Your vertex is the point, 0, 0. Okay, the next thing that I would do would be to fill in your table. So we're going to flip over to the next page. In the middle, put your vertex. You count up this way and then count down this way. Now you'll plug in these values in the x column everywhere you see your x to find your y. So you get y is equal to negative 2 squared, which is 4. So here I'll put a 4. Then I'll get y is equal to negative 1 squared, which is 1. So I'll put a 1 here. It flips on either side of the vertex, so it flips over this. So this will be 1 and 4. Then you can plot those points. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Okay, now that it's graphed, you can determine the domain and the range. The domain is a set of x values, so all x values. And the way that we write that can be like this, or you can write negative infinity to infinity. Next, we'll do the same thing with our y, so it's the y values that are shown. So the smallest one is right here, that is 0, and it goes up. So the way that you're going to write that is 0 to infinity, or y is greater than or equal to 0. Okay, let's look at number 2 as an example. Number 2, you have to do the same thing. So first you find the axis of symmetry. You find that by using negative b over 2a, which in this case would be negative 2 over 2 times 1, which would give you negative 1. So your axis of symmetry is x is equal to negative 1. Next you find your vertex. You do that by plugging in negative 1 everywhere you see an x. So this will be 1 minus 2 plus 5, so it would be 4. So you remember your vertex is a coordinate with your x, comma, y. Skip the domain and range until after you graph. So let's look at number 2, the graph of it. Remember, you carry your vertex here, you count up here, and down here. Then you plug in your values. I'm going to start on the positive side this time because I found it easier. So you plug in y is equal to 0 squared plus 2 times 0 plus 5. This will simplify to 5. So I'm going to write that here. But I also have to remember that it reflects across the 4, so that will also be a 5. Next, I can choose to plug in either negative 3 or 1. In this case, 1 might be simpler. So I plug in 1 squared plus 2 times 1 plus 5. If I simplify that, it will give me 8. Then I graph negative 1, 4, negative 2, 5, negative 3, 8. Then on the other side, you have 0, 5, and 1, 8. In most cases, the domain will be all real numbers. And remember, you can write that like this, or in interval notation. And the range will be the lowest y that you see, which in this case is 4, and then that will go to infinity. Or you can write it as y is greater than or equal to 4. And then the last example we'll do is number 3. This one automatically looks different because of that negative. So let's find the axis of symmetry. Negative b over 2a, which is negative 8 over 2 times negative 1, which in this case will be negative 4. So you write x is equal to negative 4. Next you find your vertex, which you do by plugging in negative 4. So you get y is equal to negative 4 squared minus 8 times negative 4 minus 17. So you get negative 16 plus 32 minus 17, negative 1. So your coordinate would be negative 4, negative 1. Again, we'll skip the domain and range until we graph it. I'm going to copy down my vertex. I count up on this side and down on this one. Now I start plugging in. So first I'm going to choose to plug in negative 2. Again, it doesn't matter if you choose negative 2 or negative 6. This one's a little bit harder. So you get y is equal to negative 4 plus 16 minus 17. So that will give you negative 5. So both of these will be negative 5. And then you'll plug in negative 5 and negative 3. So you get y is equal to negative 3 squared minus 8 times negative 3 minus 17. You simplify that, so you get negative 9 plus 24 minus 17. That would give you negative 2. So both of these will be negative 2. You plot your points, so negative 6, negative 5, negative 5, negative 2, negative 4, negative 1, negative 3, negative 2, and negative 2, negative 5. So it looks like this. Your domain would still be all real numbers. And your range would be, in this case, the highest y value, and then it goes down. So you'll put the negative infinity first, and then the y value that it reaches, so that's negative 1. Or you can say y is less than or equal to negative 1.